let's start writing the code. We are using a remix id for writing a smart code in remix. Create a new file, contract file. I named it lw3 token.sol. Let's create a new file, a new contract here. Okay, just create a new contract as well. Close this files. Okay, now let's copy the code. Okay, so let's break up the code and see line by line. 1. Pragma solidity. This line specifies the compiler version of solidity used. Any version greater than 0.8.0 usually would want to use the latest solidity compiler version, as a new version usually implies either new features optimization. Then we are importing the file. This line import a ERC21 token standard from OpenZeppelin in an Ethereum security company. OpenZeppelin is an Ethereum security company. Among other things, OpenZeppelin developed reference contracts for popular smart contract standard, which are thoroughly tested and secure. Whenever implementing a smart contract which needed to comply with the standard, try to find OpenZeppelin reference implementation rather than rewriting the entire standard from scratch. So basically, OpenZeppelin make the life easier by providing all the standard contracts that we can just inherit in our contract and comply with the uh, uh, ERC ERC standards. So our contract will be compiled with all the standards that provided in the contract. So you can look at the implementation standard contract if you want by following the link. You can also see the smart contract uh, that is provided by the OpenZeppelin that we are going to include it in our smart contract. Okay, okay. Note in the sophomore track, I mean that the other uh, tutorial that is provided by learnweb3.io have more detail about the ERC standard, so we will see that there. Now just see the next line. This is specify a new contract name in our solidity, while it says that this contract is an instance of ERC20. In this case, refers to the standard contract we imported from OpenZeppelin. So here we have inherited the standard contract ERC20 that we have imported. Okay, so that's how we get all the functions that's provided by OpenZeppelin ERC20 inside this contract. So now let's see. Okay, essentially we are extending the ERC20 standard contract we imported from OpenZeppelin, so all the function and logic that is built into ERC20 is available for us to use, and we can add our own custom logic on top of it. So we have all the function that provided OpenZeppelin. Now we have, as we have inherited it, so we have all this function. Now we can use it and also override the function and write our logic also. Now let's see, if you are familiar with object-oriented programming principle, you can think this is a class extending and the class. And now this is a bit has slightly weird syntax that you might not have been before. Kotlin actually has some similar syntax, but that is I digress. Essentially, we created constructor function that is called when the smart contract is first deployed. So basically, construct is always called one time when the smart contract is deployed. So within this constructor, we want two arguments from the user, name and symbol. It specifies the name and symbol of the cryptocurrency. Means name is Ethereum and symbol is ETH. So we have passed two variables, so we can pass the name of the currency and the symbol of the currency. And what happens after it is more interesting. Immediately after specifying the constructor function, we call ERC20 numerical symbol. The ERC20 contract we imported from OpenZeppelin has its own constructor which requires the name and symbol parameter, and we are extending the ERC20 contract. We need to initialize the ERC20 contract when we deploy ours.